Welcome back student to the lecture series of operating system. Myself Moushumi Shaha, Assistant Professor of Computer Science and Engineering Department, Narula Institute of Technology. Our today's topic is one of the classical synchronization problem, that is producer consumer problem. In our previous couple of lecture we discussed about what is synchronization is, how the synchronization problem can solve using semaphore, what are the semaphore variables, and then we discuss about some classical problem like dining philosopher, reader writers problem. Then we discuss about sleeping barber problem. Now today we discuss about the simplest one of the simple classical synchronization problem, that is producer consumer problem. Okay, so before starting our topic, we recall what is the need of synchronization in the independent processes they are very easy to implement than interactive processes. The interactive processes may access shared data and produce deadlock while competing for resources, and that sometimes may starve of resources in some condition. So they need to communicate some information among themselves. So we can say, therefore, there is a need of synchronization, the activities of interacting processes, and provide a mechanism through which they can communicate. Okay, so uh, the synchronization problem associated with interacting processes and their solutions, and it provides some popular method of process communication as well. Okay, so for getting shared resources like variables, buffer, device, etc. Okay, and for an interrupt-less communicating, we need synchronization. There are some cases where the cooperating process need not to synchronize, like if all the processes are read-only, that time there is no need for synchronization. No problem happen. Okay, no chaoses happen if all the processes are in writing mode. If one process is right and all other, so these are some conditions where synchronization is not affects. Okay, but there is a certain problem where we need the synchronization. Okay, so the producer consumer system, it is a system where one system produce and other item will be used. Okay, the producer consumer system, it is a system where one system produce a item and another system will be used. Okay, and the item will be used by another system. For example, if you consider a shared printer, the printer here act as a consumer, and the computer that produce the document to be printed on this shared printer are the producer. And if you think about the sensor network, where the sensors are the producer and the base station, okay, the thing they are considered as consumer. It is also called the producer consumer problem, also called the bounded buffer problem. Okay, the producer consumer problem illustrate the need of synchronization in a system where many processes share the same resources. Okay, so in the producer consumer problem, if two processes shared a fixed size buffer, that time one process that is act as a producer that put the information in the buffer, and while simultaneously the other process that consume the information from that particular buffer. So these processes do not take turn accesses the buffer, they both work concurrently. Okay, so for this we saw in our previous lecture also, the race condition happened. Okay, so the producer writes data into the buffer. Okay, so it will write in and move rightward. Yes. Okay, so the producer, okay, n, and the consumer read out the moves right way, so should not try to consume if there is no data. Okay, so if a producer want to produce one by one, it can produce data. When the buffer is full, the producer can't uh, put any value to the buffer. And same time, if you think about a consumer process, okay, it read the data from the buffer. Okay, so one time it all the item which is already the item or information which is already read, that is moved rightward, so it will change. So it will write the next answer. But the consumer should not try to consume if there is no data. If all data are already read, that time it can't read anything. Okay, so if in bounded buffer the size is n, okay, if you consider the buffer size is n and access from 0, then 1, 2 up to n minus 1. Okay, suppose there are n number of variables. So if we start the indexing number from 0, so the last position is n minus 1. Okay, and then if we wrap around after n minus 1, the next data will be produced in the, okay, so it is a circular queue. So producer produce the right data to buffer. So most not write more than n number of item. Suppose a producer want to put data one by one, so it can't produce if the buffer is empty. Okay, so it can't produce more than n items. Okay, at the same time the consumer can't consume more than n items. Okay, because the maximum value is n. The consumer process read the data from this particular buffer, and in the particular situation when no data is there, so it can't consume. This is the scenario. Okay, and look at the code of producer. Okay, while, okay, the item number equals to buffer size, that means uh, the buffer is full. Okay, suppose producer want to produce, that time first it will check the buffer is full or not. If the item number equals to buffer type, it means the buffer is already full, so it will exit. Otherwise the next produced item will be added into buffer I, and I will be increases by 1. Okay, so I plus 1 mod buffer size, it will be, that means the next item will be added into the next position. Okay, and the item number will also increase because already the current item is produced. So now the item number is increases by 1 also. Okay, and if you check the pseudocode of consumer problem, okay, so first it will check if the item number equals to 0. Okay, so do not, it will do not fetch something because the buffer is already empty. Okay, it will not consume anything because there is no data or information in the buffer. And whenever it consume an item, it will check from buffer, and this value will be decreases by 1. Okay, j equals to j plus 1 mod buffer size. Okay, and the item number is this. If we consume 5 items, next time it will consume the previous item. Okay, so there are a number of applications are there, like data from barcode reader consumed by device driver. Okay, when we uh, fetch information from barcode reader, okay, for a particular for a reader consumer by device driver. So data in a file, if you want to print the consumed by the printer spooler, which produce the data consumed by the line printer device driver. Like WebCyber produce data and consumed by client website. Okay, so there must be a question, where is the bounded buffer? Okay, so we can solve this producer consumer problem using semaphore. Okay, we will use two kind of semaphore. Okay, one is the binary semaphore, or otherwise we can use the So first we talk about the counter, okay, to track how much data in the buffer. Then one counter counts as we add a data and stop the producer if there is an object. Okay, so the counter variable will track how many data is added. Okay, and it will stop the producer if the n item is full. Okay, and the second counter count as we remove the data or we consume the data, and it will stop when the value is 0. That means already all the data we already consumed. There is nothing, okay, left. So the main idea, since the general semaphore can count for us, we do not need to separate the counter variable. Okay, because in semaphore there is a counter variable s is there, so why do not need second count of semaphore? Well, also we can also need a mutual exclusion semaphore. Okay, that means in the critical section, if one producer or consumer, any of the process can execute, then we have to wait for other process. Okay, so here, for example, a compiler and assembler can be thought as a producer and consumer processes respectively. A compiler as a producer produces the object code, and the assembler as a consumer takes the object code. Similarly, the process that gives the command for printing a file is a producer process, and the process for the printing them on the printer is a consumer process. To solve the producer consumer problem, we are using semaphore. So the following requirement we should meet. What are the requirement? I will say now, that is, the producer process should not produce a item when the buffer is full. First we have to take care of this. The consumer process should not consume if an item the buffer is empty. The producer can consume the processes that should not try to access and update the buffer at the same time. So whenever the producer process is ready to produce an item uh, and the buffer is full, the item should not be lost. That is, the producer must be blocked, okay, and must wait for the consumer an item. Okay, so before writing the code, we have to uh, careful about this, that the producer process is ready to produce an item, and that time if the buffer is full, the item should not be lost. Okay, we have to take care of this. The producer must be blocked at that time and must wait for the consumer to consume a item. Okay, when the consumer process is ready to consume an item and it check the buffer is empty, it must be blocked and it will wait for the producer to produce an item. Okay, so the another situation is when a consumer process consume an item and that is a slot in a buffer is created, that block the producer process must be signal about it. Okay, and when the producer process produce an item in an empty buffer, the blocked consumer process must be signal about it. That time, if there is an empty buffer, so the consumer is blocked. If that time the producer is producing something, that one signal is generated to the consumer that the now buffer is full. And similarly, when the consumer consume an item and it will empty the buffer, that time the producer which is blocked when the buffer is full, it will be informed by the signal that the it can now produce a item. Okay, so these are the main. So here we use the semaphore mutual exclusion. Okay, that is empty and for empty and full. Okay, initially for mutual exclusion the mutex is 1. Okay, uh, empty equals to n, it will check the number of empty buffer entries, and okay, and full equals to 0, that is number of full buffer entries. Okay, so first, the producer-consumer problem can be solved by placing a semaphore on the buffer. However, after analyzing this requirement, it is clear that we also need to check the status of the empty and full buffer for the producer and consumer respectively. Moreover, the producer process, after inserting an item in the buffer slot, must increase the value of the full buffer to indicate that the slot also of the buffer is filled. Similarly, the consumer process, after taking the item from the buffer, must be increases. Okay, so for example, the three items have been produced by the producer, but nothing has been consumed by the consumer process. So the empty and full pointer along with the current value, okay, we can see, okay. So now empty equals to n minus 3 and full equals to 3. Okay, for this particular situation, the empty and full pointer along with their current values. Okay, so here look, the code, that is we use an empty and mutual exclusion. Okay, here it will add the next item to the buffer. Okay, so this is the down, it will down the mutex, down the empty. Okay, this is the critical region. Okay, this is the critical region. When it will exit from the critical region, that time it will signal the mutual, that means up the mutual and up the, okay, it will up the empty to full, the values are changes. Similarly, in consumer, it will check it is full. If it is full, it can consume something. It will down the full, it will down the mutex. Okay, that means when wait is there, other process have to wait. Okay, then this is the critical section where the consumer can consume. Okay, when exit from the critical section, it will signal the mutual exclusion that other process can enter. That means the it will send the signal to the producer. Here it will signal the empty. Okay, because it will consume all. Okay, now true. So this is the code. Now there is difficulties with semaphore, that is wait and signal are shattered among several processes, therefore it is difficult to understand their effect. Like the uses must be correct in all processes. One bad process or program can error that kill the whole system. Okay, so we have to uh, very carefully use the wait and signal. Okay, so we see that if three items is produced, that time the empty value is n minus 3 because n buffer size is n. If the and full equals to 3. Okay, the empty and full pointer among with the current values. Okay, we can see now if the algorithm solution mentioned for the checked and adopted, then again the busy waiting will be there. The producer will busy waiting for checking whether the buffer is empty or not. Similarly, the consumer will be busy waiting for checking whether the buffer is full or not. Instead of that, two more semaphore can be taken. Okay, if we take extra two semaphore, which will count the number of empty slot and the number of full slot. Okay, before accessing the buffer, the processes need to be checked its status. Therefore, the producer first wait on the semaphore and used for the status, then the semaphore use the accessing buffer. Thus, there are three semaphore for this solution. Okay. So, thank you. Hope you understand the problem. If you have any query, you can contact me. Okay, my email ID is given. Thank you all.